Okay, welcome to a lesson that's going to be posted online as a video. We're going to go ahead and do this for the next couple weeks as a sort of experiment. It's called the Flipped Classroom. I learned about it through some online PD, and we're just going to go ahead and post these video lessons online, and then you can work on the actual problems in class, and then I'll be able to help you out as we go through there. So let's start off with a pretty easy section, 9.9, which is systems of inequalities. And the first thing that we're going to do is we're going to graph the equation, or graph the inequality. And the big thing to remember is that when we have a less than or greater than, we use a dashed line. When we have a less than or equal to or greater than or equal to, we use a solid line. The other thing that we want to make sure that we do is use a test point. Typically, we'd want to use 0, 0. If that test point makes the inequality true, we shade the region because that's part of the solution. Okay? If the test point does not satisfy the inequality, then that's not part of the graph and we won't shade that region. Okay? So we're going to get right into it, try a couple examples, and go from there. So the first example we're going to do is x squared plus y squared is less than 81. That's the equation of a circle. The equation of a circle is x squared plus y squared equals r squared, and that gives us a center of 0, 0 with a radius of r, obviously. And so in this case we have a center of 0, 0. Since r squared is 81, that means the radius is equal to 9. So I'm going to start from the center. I'm going to go out 9 units to the right, 9 units up, 9 units to the left, and 9 units down. Because it's less than, all right, that means we're going to use a dashed line. So I'm going to try my best to dash in a circle here. All right, so there's our circle. And then I'm going to pick a test point. And if I pick a test point, I'm going to choose right here, the center, which is 0, 0. If I plug that into the equation, I get 0 squared plus 0 squared is less than 81. 0 is less than 81. That makes it true, which is good. And that means I'm going to shade the inside of that circle. Those points in the shaded region represent the solution. And so now I've shown all the solutions to x squared plus y squared is less than 81. Let's try the other one. X plus 4y is greater than or equal to 9. This is going to be a linear equation, so one of the things I can do is I can set y equals 0. So if I let y equal 0, I get x is equal to 9. That's my x-intercept. Plot that right there. If I let x equals 0, I get 4y equals 9, y equals 9/4 or 2.25. It's not really a great point. There's 2.25. The other thing I might do is plug it in or try and get it so that it's in slope-intercept form. I would subtract x from both sides, divide by 4, get y equals negative 1/4 x plus 9/4. When I do that, I now know the slope is negative 1/4, which means I go down 1 and right 4, or I could go up 1 and left 4, up 1 and left 4, and you can see there's my points for that. And then I can draw my line. Since it's greater than or equal to, I know it's going to be a solid line. I should use a ruler, but I don't have one with me right now. So there's our points, okay, or our line. Last thing I want to do is pick my test point. Alright, 0, 0 works again. 0 plus 4 times 0 is greater than or equal to 9. That means 0 plus 0 is greater than or equal to 9. 0 is greater than or equal to 9. That's false. So what that means is my test point is here. That's not in the solution set, so I'm going to shade the other way. Okay, so there's my solution. All those shaded points, or all the points in the shaded region, make up the solution to that inequality. Now, when we talk about systems of inequalities, what we're going to do is we're going to put more than one inequality together at the same time. This one here is a sample of a system of inequalities. The first equation we have is this right here. It's a circle. Center is 0, 0. Radius is 5. And so I'm going to put my center right there. I'm going to go up 5 to the right, 5 up, 5 to the left, and 5 down. It's less than, so that means I need to use a dashed line. And then what's going to happen is I'm going to use a test point. I'm going to use 0, 0 again. So 0 squared plus 0 squared has to be less than 25. 0 is less than 25. That's true. That means I'm going to shade the inside part of the circle. I could shade it all right now, but I'm going to wait, okay, until I get my other graph up there. I'm going to take this equation right here. I know my x-intercept is 5, because if I let y equal 0. I'm also going to go ahead and put it into slope-intercept form, giving me negative 1/3 x plus 5/3. Okay, 5/3 is my y-intercept, negative 1/3 is my slope. So here's my y or my x-intercept. I'm going to go down 1, right 3, down 1, right 3, up 1, left 3, up 1, left 3. So there's my line. I'm going to grab my ruler. I can use the solid line because it's less than or greater than or equal to. And there's my line. If I choose 0, 0, 0 plus 3 times 0 is greater than or equal to 5. 0 greater than or equal to 5. Now that's false. So let's think about what we had. Here's 0, 0. That's not going to be on the shaded region. That means I'm going to shade this way for my line. It also means I'm shading on the inside of my circle. Alright, so final answer is going to be this shaded region. Okay, above the line but inside the circle. If I want to, and I'm getting confused with that, or I get multiple things, I could go and shade the inside of the circle because that's the solution for the top inequality, and then I could shade the top part or above the line, and then this area here where it's double shaded is my solution. Either way is fine. It does get tricky when you get multiple equations or inequalities in there. Alright, so let's try a couple more. This one we're going to add multiple inequalities. Alright, so the first one we got x plus y is greater than or equal to 3. The good thing is I know the x-intercept is 3, the y-intercept